Hello, welcome to a informal chat, I'd like to call it. We talk about creative workstations today. I'm here with Ross Collins, Solutions Architect, and Paul Hobbs, who's Creative Marketing Manager. Two guys very heavily involved in our workstations, especially our creative workstations. When we went live on the website, they had quite a big involvement in there, setting up the hardware, the use cases, what they're for. So they know a lot about it, really. So we have asked a few questions, run through some Adobe Software, what workstation is good for what, look at the hardware considerations. Basically, we are Novatech, founded in 1980, before I was born, so I'm a bit younger than Novatech, which is good. We're a systems builder, so we build workstations, servers, gaming PCs, high-end performance systems is our speciality, really. All under one roof in Hampshire, in the UK, down by near Portsmouth. Everything is there, so our production is there, we build everything, all our sales guys are there, all our support team are there. We all work in the same building, so we're a stone's throw away, really. Our marketing team, etc., customer services, everyone's in the same building, so we know each other inside out. We've got quite good chemistry, hopefully, so we talk quite a lot in the office, so hopefully we'll know what we're going to talk about. On screen now, you can see part of our mantra, really. We don't do one size fits all. That's the key here, really. We're going to be talking about what workstation is good for what program. Your work is unique, so your workstation should be too. Everyone's doing different things. One person might use Photoshop for photo editing, someone's using video editing, but that's what we're going to go through today, isn't it, Paul? Really?
Hopefully.
Yeah, hopefully. The certainty there. You're a creative professional, aren't you? So do you always use a workstation all your life?
I've used computers all my life.
Computers all your life?
Wow.
So tell Paul, be honest, tell him what you used to use. Tell him what you used to use.
Didn't you used to use a Mac, Paul?
Up until 2 years, I was 100% Mac, until I come to the realisation that they're not very good for what we're going to talk about. So now I'm 100% PC now,
wow.
At work and at home.
Work at home, there you go.
And I can play games as well in the evening, which is nice.
So you're the successful case from moving from a Mac to a workstation and never look back, right?
There you go.
Yeah. Obviously, everything we talk about in here is all about recommendations, really. Everyone's got different ideas. Everyone's got what they think is different. We'll talk about what we think. So if something you don't agree with, let us know. But I'm sure we'll agree with everything we say because we know everything. Terminology. This is where my friend Ross, the Solutions Architect, comes in.
That'll be me then, will it? Yeah.
Yeah, that will be
you. My name's Ross. I'm the company Solutions Architect. I help design a lot of bespoke systems and networks for customers that work in really all ranges of industries like simulations as well as creatives. So what I'm here to do is give you a bit of the technical ideas behind what's going on and explain what the computer's actually doing, whereas Paul will tell you about the individual programs and the software suites that we use and why certain stuff. So I'll just chime in and explain to you why things work.
You're here to correct my mistakes.
Sorry?
You're here to correct my mistakes.
Pretty much.
Pretty much.
And actually get the figures right as well. That's
yeah.
So the first thing I'm going to do is basically run through a couple of ideas that will come up a lot in the next sort of like 20 minutes or so, just so that we can try and explain it now and so that everybody has a basic understanding. Mm-hmm. So a lot of the things we're going to be talking about are CPUs and GPUs. Basically, a CPU and a GPU are two parts of your computer, two of the main parts of your computer that are responsible for handling data and doing the calculations. It used to be back in the old days that the CPU would be considered the brains of the computer. And these days it's responsible for all sorts of things like memory management, input, output, running actual programs and apps on your computer and running the operating system. In the old days, it used to be that it would also produce graphics, and on a lot of desktops and things like that, they will also have an integrated graphics solution on the CPU. A GPU is what we used to call a graphics card because that's all it used to do. Back in the 80s and stuff, we used to have CGA and VGA graphics cards and SVGA graphics cards, and they just used to produce higher color resolutions. What then happened was we started to move into 3D graphics, and we started to get graphics cards that specialized in 3D transformations, basically, and moving 3D graphics around on screens. So they're both processing units. They've got different structures, but they both basically do the same thing. They're split into cores. So cores basically is a subunit of a processor, either a CPU or a GPU, that performs an instruction on something. So data comes in, instruction, data goes out. Cores work independently of each other. They can all basically do that at the same time. And as we'll see down at the bottom there, between the CPUs and the GPUs, there's a vast difference in the cores and the sort of the number of cores, and also the type of instructions they can do. But we'll get to that in a second. The core is driven by the clock. The clock is a signal that is sent on a regular basis to the processor that says now's the time to do an instruction. So literally it's like something going now, 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 now. That clock is often measured, the speed of that clock is measured in frequency, in what's known as hertz, which means 1 cycle per second. So when you look at the CPUs and GPUs we'll be talking about later on, we're not going to give you actual data because they range a lot, and depending on how, there's no real point in us sitting here saying exactly that level of detail. But generally CPUs run a little bit faster than GPUs, and they tend to run in the millions of instructions a second. So you're talking about that clock, that signal, that pulse is 3 to 4 gigahertz. So that's a lot of hertz. So what's an instruction? An instruction is a single step in a calculation. For example, a common instruction might be add. We take 3 and 2, which are data values, we pass them to the processor, we give it the instruction to add them, and the processor inputs 5. Yeah? So that's what's going on with that. Next to any processor, you need memory. Memory is split into various different levels. There's cache levels that are on the processor, but what we normally talk about is RAM. RAM is sets of chips that plug into the board that give you space to store data relatively close to the processing unit. It's very fast compared to like your USB sticks, your hard drives, your SSDs, that sort of stuff. But it is a lot more expensive per gigabit. And on top of RAM, you've also got VRAM. VRAM is just RAM, but it's video RAM, so it's used on the GPU rather than on the motherboard. So what's the difference between a CPU and a GPU? Effectively, what they're designed to do. A CPU is extremely versatile. It has complicated cores. Those cores have the ability to perform lots and lots and lots of different types of instructions. Clever things like AVX and encryption and decryption and all sorts of really, really fancy paths, which makes them extremely versatile and makes them able to do just about any task pretty goddamn fast. Yep. Generally these days we tend to see them in the, like I said, to the very low end, 2 gigahertz up to 5 gigahertz range of clock speeds, and normally we get one, well, very rarely you get one core, but normally we'd be looking at least 4 cores now, up to 128 on the big old server chips that AMD do nowadays. The sort of stuff we'll be looking at later on, you're talking more like the 8s and the 12s sort of core count, which basically means that we can be doing 8 instructions at the same time on 8 bits of data. Okay, a GPU, in contrast, is extremely specialized. It can do a very limited set of instructions very fast, mostly because it has a lot more cores. It actually runs slower, it has a slower clock speed, but instead of having 10 cores, your average GPU will have over 1,500 cores. So what it's doing is it's doing very, very simple instructions very, very quickly, which allows it to take certain types of workloads like graphics. If you imagine moving a triangle in a 3D space is basically performing the same calculation on 1,000 points at once. That's what a GPU is really good at. So it's really, really good for speeding up really simple parallel workloads. So that's basically the differences between a CPU and a GPU. Paul will talk a little bit about how, in a CPU's case, that efficiency gain from having more cores basically flattens out.
So yeah, so if you basically, it's how well software can utilize multiple cores. So if you take, say, Photoshop, it works really well up to a certain point. Say up to 8 cores, be really efficient. After that, that kind of tails off. So if you add more cores, it's not going to go any faster. If you look at something that's made to heavily multi-threaded, like Keyshot, for example, which is a CPU renderer, the more cores you add, that line will just keep going up at a steady rate. Some programs or some tasks can only use a few cores at a time. Then no matter how many cores you've got on your processor, your CPU, it will just level off. So the speed or the speed of the process will stay the same. That's pretty much it in a nutshell.
Yeah, I think what we're trying to do now is look at, like I said before, we're going to look at certain use cases, and you're going to go through recommended CPUs, GPUs, storage, memory, etc. Yeah.
Yeah.
What will happen as we go through these as well is that, like, Paul and I will jump in and explain some of our choices and explain some of the background to it as well, rather than just sitting and going through and talking for hours about CPU architectures and instruction sets, which I'm more than happy to do.
Which you could do, but that's...
We'll be more than happy to listen to.
Another day.
Discussion for another day, Ross, that one.
Obviously, next is efficiency. Do you want to talk about the cores?
We just done efficiency.
Yeah, done really. So first one is image and photo editing. So you got like Photoshop, Lightroom, etc.
Yeah. So as I just mentioned, so Photoshop and Lightroom can both use multiple cores, but only up to a certain point, really. So once you get to, say, 6 or 8 cores, your level of performance is just going to drop off. Well, not drop off, it'll ease out, it'll flatten out. So what you really need, because these are either single-threaded or lightly threaded tasks, it's only going to use a couple of cores, so you want those cores to be really fast. So ideally, the sweet spot would be something like 10700K or 3800X. The 3800X is slightly faster in synthetic benchmarks, but real world, you probably won't see a massive difference.
So just jumping in for a second,
yep.
The reason that this is multi-thread, we need to talk a little bit about threads, don't we?
Yep.
So what happens within a program is that each core can basically run 1 or 2 threads, which is a series of instructions running different functions. What tends to happen with CPU processors and application processors such as Adobe and stuff like that is that CPU tends to be fast for running deterministic threads, so things that tend to go in a certain order, for example,
like
or things that happen. So when the software engineers write the software, there tends to be multiple sort of a simple task that you might be doing, for example, applying a filter in Photoshop. It's probably broken down at stages. It's probably the actual filter, say you want to put a Van Gogh filter on or something like that, it's probably a sharpen and then a blur, then something else. And each of those is an individual process that works on the basic. What happens when you multi-thread something is you split those different tasks up into different streams of information and then increasing it. There are a lot of things that we'll talk about later on that you can't multi-thread simply because you need to know what happened to your original calculation. So that's what Paul's talking about when he's talking about single and multi-threaded and lightly threaded workloads.
Yeah, thanks, Ross.
It's all right.
Yeah, so CPU, they are absolutely fine for Photoshop. Adobe, Photoshop and Lightroom both support GPU accelerated processes. They're both quite light, but they can help out with things like filters, blurs, noise reduction, They help out in camera raw, so when you're panning around and doing little bits, it'll speed that up. But you don't need anything crazy. They say about 4 gigabytes of VRAM, so you're kind of looking at mid entry-level GPUs. It will run an integrated GPU, but it'll be a lot slower. So the 1660 Super is absolutely fine for most tasks. You can bump it up to a TI if you want, be a bit quicker. But again, it kind of depends on the files you're working at and the file size and the resolution and the effects that you're running. But
is there? Obviously, I'm looking at these. You've got a GTX 1660 and RTX 2060. Is there?
Yep.
Sort of. Is it? I mean, is there a huge contrast between the generations, or
in Photoshop you won't see a massive difference. Okay. I mean, obviously the RTX has got the ray tracing cores, the RT cores.
Yeah.
Yeah, so
it doesn't support them yet, but in the future, maybe for certain things.
Okay. The primary difference between a GTX and an RTX in this case, both the cards that are quoted are Turing architectures, so they're TU chips, but the RTX has additional ray tracing cores or RT cores, as well as tensor cores to help with some AI-based workloads and neural networks and things like that. They run TPUs as well. Which I'm sure we'll talk about when we get to video rendering.
Mm-hmm.
Yeah. Memory. Yep. Sorry. I think we're done on GPU. It's probably worth adding that if you've got a really fancy monitor or color accuracy super important, you can download the studio drivers and video studio drivers, and that supports 10-bit color. It used to be that you had to have a Quadro card to get 10-bit color, but it's not the case anymore.
Nice.
Okay, so in terms of memory, 16 gigabyte kind of standard. That will cover sort of most of the jobs. Yeah, kind of. Yeah. Again, it completely depends on the file sizes you're working with, but 64 gig, I would say, would be the maximum you'd ever need for Photoshop, unless you're doing something really, really crazy and have lots of files open at the same time.
If we look at the storage part of it, I mean, we're going to see this similar storage strategy for certainly in the next couple of slides. Simply because it's just the most efficient way. And storage is an interesting topic as far as like workflow goes, because we have to talk about very much the slowest part of any process here. Is moving data around. Like any time that we have to move data from a network to a PC, or from a hard drive to an SSD, or an SSD to a graphics card, any of those flows, that is effectively probably always going to be the slowest part of any process. It will look differently, as in there will be a lot when you're rendering. A lot of time is obviously spent working through the CPU and the GPU, but those operations are going a lot quicker. It's the storage that can basically speed that up to a certain degree. So failing to address your storage properly, especially in creative workflows, can really seriously hinder your
it's a bottleneck. It'll slow you down.
Yeah, it's a bottleneck.
Yeah. So we always recommend NVMe for the boot and application, just so everything runs really fast. And then you'd have a.
Do you want me to explain what NVMe is?
You can in a sec.
Time.
We have a larger SSD for your project drives, nice fast SSD, and then ideally, preferably, a separate scratch drive, and that's the kind of temporary storage for Photoshop. So whilst you're working, it will dump all of its temporary files, history states, that kind of thing.
So you want a separate
scratch drive?
Ideally, drive
Ross can probably explain why in terms of IOs and all the rest of it. And then just a big old mechanical drive, just sat there as an archive drive.
I mean, you can get decent sized mechanical drives now, can't you? If you're looking for a beefy drive.
They're super cheap.
16 terabytes, I think. So you get doing Iron Wolf nowadays. Obviously, we do include. We'll probably end up having to do one of these on backup at some point, and we do recommend having RAID and backup strategies in place to make sure that you don't lose your data and all that sort of stuff. We would never recommend having a monolithic mechanical drive as the sole source of your data repository. That's a very easy way to kill your business.
That's a favorite one,
So NVMe is a solid state technology that uses a particular type of I/O known as PCIe lanes. So what happens with NVMe is that the hard drive or the solid state drive is plugged directly into the CPU via a bus, and it can be directly addressed by the CPU rather than having to go through a storage controller such as SATA or SAS. SSDs themselves are normally SATA, and they are normally plugged into a SATA controller. We're talking about 6 gigabits a second. That's fine for most stuff, especially it's quick for storage. If you've ever loaded a game off a mechanical hard drive versus loading a game off an SSD, you see it a lot quicker loading there. But NVMe is another step up. And nowadays, we're even starting to see on the latest AMD chips, we're starting to see PCIe 4, which is the next standard. We're starting to see NVMe PCIe 4 hard drives that are, even 5 times faster than the NVMe drives we're currently using today. As far as the scratch drive goes, what's happening there is that Photoshop is dealing with a lot of data at the same time, and it needs to it will overflow the memory if you don't have enough memory. If you for some reason you had a terabyte of RAM or whatever, you wouldn't need a scratch drive because all of the memory would be deliberately loaded into RAM, all of the work that you're doing. Having said that, Photoshop needs somewhere to store those very large files and those large temporary files and large cache files, and it needs to be as fast as possible, basically, which is why we use NVMe. The closer NVMe doesn't have to go through another controller. It talks directly to CPU, and generally, the closer something is to a CPU, the less distance it has to travel, the faster the load times.
I mean, just to cut you off there. So if you're having a boot drive and a scratch disk drive, they don't need to be huge sizes, do they? If you're using just for that. So like obviously your project drive SSD can be quite large, but your scratch drive and your boot OS drive don't have to be a huge amount. Is that right?
Your OS, basically, your OS drive is just going to have your applications on it and your OS. So
yeah,
I mean, the scratch drive, you don't want to have a drive and run out of space, do you? Because you don't want to see that dreaded your scratch disk is full.
Scratch disks are full. No, I mean 64 gig, 128 gig.
Yeah,
it should be.
It's actually quite hard to find 128 gig SSDs these days.
Is it?
They're normally at 256. Yeah.
Okay.
The other thing that we need to cover is that you want to keep your boot drive and your scratch drive separate. Mm-hmm. You can use folders on your scratch drive, and you can use your boot drive as a scratch. Having said that, because you're going to be switching between different parts of your SSD while you're working application, Windows and your application are going to be talking to your boot drive constantly. Even if you just look at rest, I'm just sitting looking at my performance graphs now. My SSD at the moment is just idling at 5%, talking to various different programs. Just it is doing a couple of things in the background, but that I/O is just yet another way of slowing things down because it's taking away from from the scratch drive. So each controller basically has to be able to talk to its own drive independently.
Sure. Should we move on to video editing? Next one. Any more on photo editing? Anyone?
Oh, that's about the same. We didn't really touch much on Lightroom, but it's pretty much the same as Photoshop.
Yeah.
Handles multiple cores a little bit better, but it's pretty much the same.
So video editing. So you got like After Effects, and how much does it differ to photo editing? I mean, I can see the bigger one is a CPU. Yeah, you've gone on from an i7 to an i9.
Yeah, so more cores. So yeah, it's a lot more demanding. You do definitely need a better system to run it efficiently. It's not as multi-threaded as it used to be. They took a lot of it out just because it wasn't very stable. So they've sort of gone after GPU acceleration. So yeah, you don't up to about 10 cores should be fine. Again, because similar to Photoshop, because you've got lots of single-threaded and lightly threaded tasks, you still want a fast CPU, so high frequency. So the i9 10900K is 10 cores.
10 as well, isn't it?
Yeah. what's the base on that, Ross? 3.6 is it base clock, but it runs happily at about but it runs happily about 5 gigs.
Nice.
Then you got the Ryzen 9, which is a slightly slower, but it's got 12 cores. So
it also has a slightly increased IPC ratio, which is instructions per cycle, which means that clock speed that's driving the instructions on different processors and different architectures. It can execute more than one instruction per cycle. So a lower clock speed on a current generation Ryzen chip is the equivalent of a higher clock speed on an Intel chip at the moment, because it has an IPC benefit. There you go. Random facts.
That's good.
It's good. So that's about what you need for CPUs.
More cores, yeah.
You can, it will, if you're exporting, it will make use of more cores. So you could have more cores if you want. But for sort of general use, 90% of your workflow is just going to be, anything over 10 cores, it's not needed, really.
Yeah. So one of the things I think we've talked about previously, just between ourselves, is how the sort of NVIDIA and the AMD cards here are used in encoders and decoders on the cards, part of the chipsets, to increase particularly like encoding into different formats for video, which is much more important in video than it is in, well, it's not even applied to photos, is it, Paul?
Not really, no.
So, graphics cards?
Graphics cards.
Just one thing to pull out there as well is that Paul's put down there that 8K needs 128 gig of RAM. Obviously, that would require a different processor than the ones we've listed, but it will need to be the 10900X or a Threadripper.
Or a Xeon W.
Xeon W.
Yeah, but obviously with that you do lose some of the speed. They're generally not as fast as the i9s or the Ryzens, are they?
No.
Generally more reliable, but it's a trade-off, isn't it? Reliability and speed. And obviously extra PCIe lanes and memory channels, which is nice. Anyway, graphics.
Got the same graphics cards as
just like Photoshop. Yeah, so a lot of the tasks now are GPU accelerated. Some task processes are only work on a GPU. There's no CPU fallback, so things like VR blur, that kind of thing. But it doesn't need anything crazy. So again, a good mid-end card, the GTX Super 1660 Super again, should be absolutely fine.
Okay. Interesting. Memory?
Memory, very important. After Effects loves memory. So when you're previewing your video, it'll basically load that into the memory, so you get nice speedy playback. The more complicated your scenes are, the more effects you've got, the length of it, that all kind of determines how much memory you need. So as a starting point, 32 gig. I wouldn't really go any lower than that.
Okay.
And as you go up the resolutions, 4K, 64, and obviously up to 128.
Beefy, and your storage is pretty much the same setup as
exactly the same. Yeah, you might possibly want a bigger project drive, because obviously you're working with bigger files, but
your Stereo Scratch and your boot OS drive same size.
And for it's that same reason as well.
Storage and memory, just as we should say, the reason is obviously as the pixel density increases, the size of the files go up exponentially. So it's not like 1080p to 4K is not it's not just twice as much. I do believe it's 4 times as much, and then it's 16 times to 8K.
Sure.
So moving on. I mean, what would you say, Paul, is the most important thing here about where to spend your money?
If it was me and all I was doing was using it for After Effects, processor, memory, fast drives, I would probably spend a tad less on the GPU.
I think that's a good point that we probably should have made earlier on, is that the fact is that we all work to a budget.
Yeah, of course.
And that we these aren't cookie cutter PCs. If you have X amount of money, we can tell you where it is better to invest that money, and it will only be up to a certain point where that spending that money will get you that increase. So moving from a 2060 here to a 2080 Ti is a significant increase, but which is probably the equivalent sort of money is moving from 32 gig to 128 gig. Having said that, it does not give you the same sort of return on investment.
No.
It's very obvious that that's a better graphics card and that's the sort of thing, but it might, and that might very well pay off in a gaming system or a render system or something different. But very much this is what we were trying to talk about before, is like there is no such thing as a perfect workstation. Yeah. Where a company like ourselves can come along, and our sales representatives and stuff like that who work in verticals and who are experienced with sizing units like this, they can very definitely come along and talk to you about what you need and how much money you have and where that money should be best spent.
Yeah, that's right. Yeah, I mean, double the price doesn't mean double the performance. In a synthetic benchmark, it would, but when you're using it for real tasks, doesn't add up. I mean, you could go out and buy a AMD Epic CPU with 128 cores or whatever it is, but it won't perform as well as these for this task. Ross said about the 2080, for the difference between the 2060 and 2080 Ti. You probably see, I don't know, 5-10% uplift. So you're spending a lot more to
3 times the price sometimes.
Yeah, exactly. Yeah. So obviously, will be better, but it's a price performance thing, isn't it?
Yeah. So obviously, when you're looking at one, you want to start out with your budget, what it's for, and work from there. Really, that's what we're trying to say.
Yeah. Prioritize the components.
Yeah.
And it's just getting the best fit, isn't it?
Absolutely. So the next one is video editing again, but Premiere Pro.
Premiere Pro. Yeah. So bit of a different beast. Yeah. So start with the CPU. Again, a lot of it is multi-threaded. About the same as After Effects, so you don't need anything over really 12 cores. It will make use of more, but as soon as you go over 12 cores, that performance efficiency is going to drop off a little bit again, kind of flatten out. The most important thing, equally important thing nowadays with Premiere is probably the GPU. So Adobe have really gone after GPU, just because the technology's advanced so much in the last 4, 5, 6 years, whereas CPUs have kind of stagnated a little bit, so they've put all their development time into making the use of the GPU. So nowadays, encoding, decoding, color corrections, live playback, effects, filters, they are all GPU accelerated, and that'll speed up the workflow by up to 15 times.
So you got here. Sorry, you got up to 4K, 8K. You got the RTX. Why would you need a Quadro or a Titan? So
it's basically the VRAM. Again, the bigger your file, the more effects you're using. If you're running 8K footage from a Red camera, that's going to be a chunky old file. And because this is reliant on the GPU, you need that VRAM. It'll pump it all into the VRAM. And if you run out of VRAM, it'll slow down. So for most cases, up to 4K, 2070 should be absolutely fine. 8K 2080 Ti. If you need additional VRAM, if you're running out of that, then you can bump up to the Titan RX, which has got 24 gig. And then Quadros go up to crazy amounts of VRAM. Obviously, you're going to pay
up to 48 gig on some cards.
Yeah.
And one of the things I would say about the Titan and the Quadro in particular, that you have there as well with Premiere Pro. Correct me if I'm wrong, Paul. It's a lot to do with rendering your when you export your video. It's to do with compiling all the clips into one long thing. It's a one long process, which is
so when you're encoding, So it will split it out with the CPU as well. It can make use of both.
Yeah, but with that sort of stuff, with the Quadros and the Threadrippers and stuff, you've got a change from a desktop PC and a desktop parts to workstation parts and professional parts. So Quadro, the difference between Quadro and RTX cards is they use the same chips, but they use different methodologies, shall we say. They're the same architecture, but different priorities. A Quadro card, for example, an RTX 4000 will use the same chip, I believe, as a 2070. Having said that, it will have substantially more VRAM. It will have substantially different components on. It is designed to run 24/7. It's designed to be reliable. It uses ECC memory. It has a bunch of extra features designed to make your process more reliable rather than just fast. This applies in this case because you're exporting a project. That could take, if you were exporting a very long film, for example, that could take hours, if not days. If you are doing that and your card has an issue or you hit a problem through no fault of your own or no fault of the unit and it crashes, then that is a significant time investment that you've lost. Yeah. Whereas if you're running a video game and you generate one frame incorrectly, you're never going to notice it. Therefore, Quadro cards in particular have an emphasis on reliability and accuracy that RTX cards don't, and obviously that is reflected in the price tag.
Yeah, that's what you're paying for. It's the R&D, right? Like you say, same chips, but it's all the certifications that go into it. And
it's the RAS, the reliability.
Testing, yeah.
The other thing on there that we didn't tackle is HEDT, which is high-end desktop. Mm-hmm. So high-end desktop is the same as workstations to a certain degree. They're bigger chips, more cores, different chipsets. You start to see features such as remote management of motherboards, ECC, which is error-correcting RAM, that prevents more blue screens and runs at a slower rate. The emphasis definitely changes from that quick and dirty, shall we say, to that slightly slower, more methodical, but 100% solid.
So is that the Threadripper? Is that what?
Sorry.
So the high end desktop. Are you referring to the Threadripper here? Or?
Yeah. So the 3970X, I think, 32 core, 64 thread. It's still pretty fast. I think it's 3.7 base. And like I said earlier, for most of your work, you're not going to notice a massive difference. But when it comes to that multi-threaded stuff, where it can really kick in and use all those 32 cores, then it will just wipe the floor with the other guys.
Yeah. Huh.
And of course, you get extra PCIe lanes. So if you want more GPUs, it opens all that up for more GPUs.
Okay. And your memory here is pretty much same as the same outline as the After Effects. Isn't it?
Yeah. Again, because it relies on the GPU more. It doesn't use the system memory quite as much, but you still need a fair chunk.
So if you're looking for 8K, you've got a beefy machine here, haven't you?
You need a beefy machine.
Yeah. And your storage pretty much same as the previous. You've got the same layout. Again,
obviously, adjust size depending on what you're working with.
As far as 8K goes, a little bit of a tangent. It's an interesting thing because previously the only way you could deal with red footage, like 8K footage, was using Red
Rocket. Yeah,
which used to be a separate hardware-based encoding card.
And they're about £6,000 each.
Upwards of like £5,500, £8,000 just to help you handle that footage.
Yeah.
And it just goes to show how powerful a 2080 Ti is. Mm-hmm. The fact that it is a graphics card and it can also handle that now without the exponential price tag that they used to have.
Yep.
They're just going to come out with 16K next, aren't they?
Yeah, probably.
Yeah. So, moving on to design and animation. So you've got Cinema 4D, etc. Obviously, this looks a bit different. To be honest, you don't need anything crazy for design and animation. This is different CPU rendering. Obviously, if you've got a CPU rendering, that's a completely different system. But most of it is single-threaded, so it's only going to use one core at any time. So when you're modeling and building something, it's only using one core in your CPU. Okay. So you want to get that as fast as you can. Again, so the 10700K or Ryzen 7, both really fast CPUs. Mm-hmm. They've only got 8 cores, but you don't need any more than that. It's just wasted after that. Obviously, if you're running some sort of simulations, then it will use more cores, but 8 cores is probably about plenty. Sure. In terms of GPU doesn't do a whole lot. GPU basically helps with the playbacks of the frame rate in your viewport. Okay.
so you don't need anything crazy there. And again, same with the memory, really. Depending on the models you're working on, how complex they are, then you might need a bit more. But 16's normally plenty for most people. Can go up to 32 if you need to. But
And how comes your storage is different here?
so all you need, you can run the application and the OS all from the same drive.
Okay.
So you run it all from the NVMe from your boot drive, application drive.
Sure.
And then obviously, if you're saving projects, I would still preferably stick them on a SSD. If you've got a bunch of textures, you want to bring those across quickly. You don't want them chugging along on some old mechanical drive. So still recommend a SSD, fast SSD as a project drive.
But no need for a beefy mechanical drive here.
No, you're not producing massive files.
Yeah.
I mean, this sort of stuff you could kick up to the cloud. Whereas obviously with Photoshop files and big videos, that's just not feasible, really. So yeah, and obviously there's nothing stopping you. You could have a mechanical drive on there, but
there's no pressing
really
need.
required. No, I personally I wouldn't. But again, if the type of person who's generating huge texture files, then yeah, sure, you might want a mechanical drive to kick everything across once you finish the project. Yeah.
That's fine. Next one is GPU rendering. So you're looking at your Redshift and your Octane here.
Yep. So again, processor. It is important and it's not important. So for actually running the software, it's the same pretty much as what we were just talking about, setting it as a single core, and it will do a little bit when it loads the scenes and whatnot onto your GPU. I mean, Ross, you want to talk about PCIe lanes and why it's important for the...
Well, yeah, I mean, what the processors are doing in rendering most of the time is just scheduling where things are running where, and also moving data around. I mean, the big problem here then becomes when you've got multiple graphics cards. So graphics cards are talk to the CPU. So if we think about where our data is, our file is initially on an SSD or a storage device. We have to get that SSD, move it through the CPU into RAM. Once it's in the RAM, we need to move it back through the CPU down into the graphics card, into the VRAM, and then from the VRAM it can be moved to the GPU. Yeah? So the big sort of bottleneck here, when you have on most desktop processors on a 10700K, is PCIe lanes. So the connection between the GPU and the CPU is called a PCIe bus. In which case it normally uses 16 lanes, each of which has a certain bandwidth capacity. The CPU only has a certain amount of lanes available, especially full speed ones. And in this case, if you increase the number of GPUs that you're plugging into that CPU, you're reducing the bandwidth that each card can get. You can counteract this by increasing the moving to progressively larger chips with more PCIe lanes. For example, on some of the AMD EPYC second generation stuff has up to 128 lanes per chip, which allows you to get a lot more GPUs in to address the different cards that you've got plugged in, basically. Yeah, that's it.
I mean, the key thing I'm seeing here is as many RTX cards as you can afford. So, I mean, are you saying the more the better? Yeah.
Yeah. Well, the thing with GPU renders, Octane Redshift, if you've got one GPU and you add a second one, you're going to double that performance pretty much.
Okay, so you get the actual double, yeah. So
it's a massive increase. Add another one, you triple it. Another one, quadruple it.
Okay.
So you can go up and up and up. The best kind of bang for buck card at the moment, I guess, would be the 2080 Ti. And you can, if you get a blower version, you could stick 4 of those together in a workstation. Yeah, that's gonna work really nice. The only time we'd kind of recommend going up to Titan or Quadro is if, again, you need more VRAM. Because what happens is when you set off a render, all your scene files will get dumped onto the VRAM of the GPU. If you've not got enough VRAM for that scene for your project, then you're going to get render failures pretty much. At the moment, NVLink, which we can talk about NVLink in a bit, Ross, but it doesn't pull the memory together. So if you've got 4 cards, each of 11 gig, and they're connected, you're not going to get 44.
Okay.
You're still only going to see 11 gig. So yeah, if you need additional VRAM, then you can go up to Titans or Quadros.
If you were to have 4 RTX 2080 Ti cards, like you said, do you then need a high-end desktop CPU there?
You need to, otherwise, if you don't change your CPU, if you don't go for something called PCI Express lanes that Ross explained, like Threadripper or Xeon or whatever, you wouldn't really go Epic in desktop. That's more of a rack mount solution. But I mean, you're just creating bottlenecks. They will still run, but they're not going to run at full speed.
And you're not
so
getting
you're wasting your money. Yeah, exactly.
Yeah.
It's basically what happens there is that there are methods of doing it using what's known as PLX switching and PCIe switching.
Yep.
But you're basically cutting down the amount of time that they have access to it. So you end up with oversubscription to the PCIe lanes. Yep. So when everything's trying to push data down or pull data up, it just can't do it as quick as you can. So you can't run it at the fastest thing. Mm-hmm. At the moment, that's generally like above a ×8 slot. That's generally only a problem for 2080 Ti's and high-end Quadros. Mm-hmm. But to be honest, if you're in the situation where you're going to be putting multiple cards in and you're going to be putting multiple 2070s in, then you're probably better off putting a single 2080 Ti in anyway. It's going to run less power and it's going to give you more bang for your buck generally than running 2 separate cards. And the days of SLI are pretty much done. Mm-hmm. It was always a bit of a crapshoot, but
wasn't really a thing, was it? SLI didn't really take off, did it?
It's just not very efficient.
No.
You'd get maybe 30% better frame rates.
Sometimes worse.
Yeah, depending on how well it was optimized, because it had to be a custom solution for different games.
Yeah.
But with rendering, it becomes a situation where, you know, when you're doing this seriously and you're running 4 or 6 or 8. I mean, we've built rigs up to 10 GPUs in a single rig for this sort of stuff. When you're building those sort of GPU rigs, you want to be using dual processors, server grade kit. You're suddenly moving it into, you're generating a massive amount of heat, which is restricting everything. It'll literally cost you, you know, thousands of pounds a year in electricity to run these things. You know, there is more to this, like there is everything here. There is more to this than just increasing the number of RTX cards. Yeah. You know, there is economies of scale and ways to do this. And again, this is another one of those examples where reaching out to talk to someone like me, or someone like one of our sort of like specialist workstation salespeople, they've seen a lot of different people's builds, and when you see a lot of different people's builds, you can see the good things and the bad things that different people do. Shall we put it that way, politely? And I won't say I've seen some shockers, but there we go.
I mean, I'll name drop here, but obviously we had Gavin Strange from Arbin Animations, and he had a GPU rendering issue, didn't he? I remember. What was he using before?
Yeah, he was on a MacBook.
MacBook, wasn't he? Yeah.
4-year-old MacBook.
And he was struggling for hours, wasn't it, and failing.
So he just wouldn't run it. He was trying to run Octane.
It
just couldn't handle it.
And you moved to a workstation with a Quadro in there? Was it Quadro?
Quadro RTX 6000 with a Xeon W, I believe he's running now.
So he runs like a dream now, yeah.
You could do things real time now. So you know, you're working on your model, drop a light in, you can see it real time, spin around your model, place things the way you want it. Whereas before, obviously, you'd have to line it all up, get it to how you think you want it, do a little test render. If you're happy with that, run full-on render which could take ages. You're happy with it, change a little bit, do it again. Now you can do it on the fly now.
Yeah, and again it goes back to the point that both of you have made constantly is, although the hardware is a bit more expensive, you're not wasting your time. So obviously you're spending a bit more on the hardware, but you're saving your money, your time.
If you think about it, if your daily rate or your hourly rate is, I don't even know what an hourly rate for a graphic designer is, but if you're charging your time out as a company at $50 an hour, for example, or £50 an hour, if you lose 30 hours or a week's work because you've bought something that takes longer, or something that quite easly over the course of a year's rendering time, you can lose a week worth of rendering time. Then you've lost £1,500, haven't you?
I think just as important now, it enables you to play. You know, like creative people, they like to tinker and try new things. You can just do it on the fly now.
This sounds awful. It should be pre-planned and all linear. How dare you run your test reds on my beautiful linear? It's not as efficiently use of my render farm, Paul.
Sorry, mate.
Memory and storage similar to so you got the
we should be saying stuff around now about network storage. Rendering becomes a different beast again. So with rendering, a lot of the times here you'd be using a separate GPU rendering cluster or machine farm or various different things in a big company anyway. And then we need to get into various interesting conversations. Well, I say interesting, but you guys are finding them really boring about networking and network attached storage and NFS mounts and InfiniBand and very niche stuff like that. But again, this is the sort of thing that if you are looking at scale, this is the sort of problems that you might find. There is no answer. There is no single answer to any of these questions. Increasing various things will always increase the bottleneck somewhere else, and it's about the experience of knowing which bottlenecks are worth tackling in what order, rather than just throwing money at a problem. And again, understanding the problem in the first place. Turning around to, like, Paul often says to me things like, "Oh, I've got somebody that I'm working with on social media, and they want a workstation, and I want to help them out." And then I go, "Well, what are they doing?" And he'll go, "Name a program," and I'm like, "Yep. What's he doing?" that program does a lot of things.
Yeah.
What's the actual problem we're trying to solve here? There is no easy answer.
100%. There is no Premiere Pro workstation, because the workflow and the way people work is so different. The way I work is going to be completely different to the way someone else is going to work, and the demands placed on inefficient. I do work inefficiently. Yeah.
So I think from what all we've covered is obviously on our website we have lots of workstations listed. They're not going to be off the shelf things all the time. Like it may be that workstation there is perfect for you, but they're all customizable. You can change bits. You can change the GPU. You can upgrade the CPU. I think that's what you can do on our website, and also you can talk to someone.
That's very much a very important thing. Like when the workstation and server range that's up there at the moment was developed, and Paul worked very, very hard on that. I mean, a lot of those they're very much starting points, and they're all configurable. We spent more time working on the configurator to a certain degree than we do working on the workstation, because the workstations change a lot when new technologies come out. But that ability to sit and easily change parts of the build and things like that, that's a very important thing. You can always, if you prefer to, if you're a more visual person, you can always call our inbound calls people and bring up the configurator on your screen and have them talk through the different options and why they would change things around. That's much more of a way that we work, rather than HP with a Z4 and they sell prefix configurations, and if you want to try and get it changed you have to raise a bid price, and it's not like that basically. And plus, if you want to do something really, really cool, we'll probably just build you something from scratch.
Exactly, yeah. So I think the key is to work out what you're doing, what you're using it for, what your budget is, and then talk to us, and we can make a few options.
Work out the best fit for what you're doing.
Absolutely, yeah. And make sure there's no wasted money there on any wasted hardware. Essentially, yeah. Anything else you want to cover, or are we?
Calling. We've not touched on calling.
Oh, calling, yeah. That's
calling. It's not very exciting, but it's very important. We did some testing on the 10900K.
Yep.
And we got a bunch of air coolers and liquid coolers, and on some of them the performance was all over the place, just because these processors run so hot. If your firmware gets too much, it will throttle the CPU, so your speed drops right down. So yeah, calling. Definitely.
That goes back to the sort of experience. I mean, we do work a lot with these programs, and we do know what we're doing, but what we really know and what the sales guys really know is hardware, and that's where our experience in building literally thousands of machines a month, that's where our experience comes from. We know how to handle the heat and stuff like that. You can do your research and you will possibly know more than the person you're talking to about what processor you need. But I'll tell you what, that person you're talking to will know how to get that processor running to its best point of efficiency, rather than not necessarily saying you need this for this program.
Yeah.
And that's about it, guys.
I think I'll put a link in the details below to that call-in blog post, so you can look at the results of that. But apart from that, yeah, thank you very much, guys. Appreciate that. We'll
No worries.
have to go for another sector soon, so maybe a bit of deep learning. That'll be do that in about half an hour. Yeah.
Get that done. Get that done in 5 minutes.
Yeah,
Easy.
not a complex one. But yeah, thank you very much. Hope this
Humans.
there's some interest to you. If you have any questions, let us know. We'll put all our contact details in the bottom, so you can contact our sales guys if you've got any questions. Yeah, thank you very much.